Welcome back to Mr. G Does Maths. Another nice problem to have a go at here. It's actually from the Senior Math Challenge that has just taken place. And it was actually the one question that quite a few of my students asked me about afterwards. It, like so many of these problems, actually just requires, albeit high level, but a GCSE knowledge of how to deal with certain shapes. I won't give you any more clues. Before you try, let's remember this is a non-calculator paper. So within that, there's a few hints as to what you should be doing and definitely what you shouldn't be doing. Either way, pause the video, give it a go, and I'll be back in a second. Okay, so clearly the issue here is we've got a triangle, but we know nothing about this triangle except for the angles. So the lengths could be anything. It's a similar triangle whereby we could scale it up or scale it down. Except, of course, we can't because we know it's inside a circle of radius 2. So if we just kind of have a go and draw these radii in here, we can see that all of these must be isosceles triangles, all of length 2. Now the problem is it looks like we can halve the 75, halve the 60 and halve the 45, create the middle angles, but of course we can't do that because we're not sure quite what ratio we're cutting the angles into. There must be another way of doing it, and the solution to this is really quite neat. And again, it's once you've seen it, it's obvious, but until you sort of spot it, you can be staring at this for quite a while. Let's take the example of these two lines here. So if you think about these two lines here, they both come from the same arc as these two lines here. Apologies for the terrible drawing. So these two lines here, which means it must be the case that this angle here must be half the angle at the center, which is this angle here. So actually what we can work out is it's nothing to do with dividing the angles up, it's actually to do with doubling the angles, which will tell us that that's equal to 90, this one's equal to 150, and this one is equal to 120. We still haven't solved it though, we still have a bit to do. So if we just zoom in a second so we can see what we've got. Now at this stage we do feel a little bit better. We know something, we learned this at GCSE, we use it again at A level. We know the formula for an area of a triangle is going to be a half times the side, sometimes called A, times B, times sine of the angle in between. Well, in this case, I know what the A and the B are. They're both 2, because it's an isosceles triangle, they're both radii, and I know the angle in between. So I was going to have to think a little bit about what the value of these angles might be. Well, the angles that we need to learn at GCSE are the angle sine 30 equals a half, sine 60 equals root 3 over 2, and sine 90 is equal to 1. Which, as we remember from the formula, that sine 180 minus x is the same as sine of x. That must be the same as sine 150. This must be the same as sine 120. And actually sine 90 is one that we need already. So now we can bring this all together. If we label the triangles we know what we're doing, we'll call that A, we'll call that B, and we'll call that C. It means the area of triangle A is going to be a half times 2 times 2 times 150. The area of B is going to be a half times 2 times 2 times sine of 90, 1. And the area of triangle C is going to be a half times 2 times 2 times sine of 120. And again, I know these values from above. So in other words, this is going to be a half times 2, which is 1, times 2 times sine of 50, which is a half. That's going to be 1. A half times 2 is a half, times 2 is 2, times sine of 90 is 2. And a half times 2 is 1, times 2 is 2, times 100, sine 120 is going to be root 3 over 2, cancel the 2's, it's going to be root 3. Add all of this up, and I get root 3 plus 3, which is going to be answer E. Hope you enjoyed the video. Like and subscribe as ever. We'll try and post a bit more on the channel going forward. Thanks a lot. Bye.